Hey guys, and welcome to your next C++ and OpenGL tutorial. In this tutorial, what we're going to do is implement font rendering because we haven't had any way to render text yet, and it's really important for a game. We want to have a main menu, we want to have a heads-up display, anything that uses font. Right now, all we've been able to do is write text to the command prompt, and that should really only be for debugging. We shouldn't be using that as the main way to present text in our game. So to actually do this, what we're going to be using is a TrueType font renderer. Now, TrueType font is a type of font that you can get online. Just you have them installed on your computer by default. Probably you can go find some of those. Or I have a TrueType font, this chintzy.ttf. It's just a random one I downloaded. You'll find a link to download this in the description, or you can pick any TrueType font you want. We want to be able to render these TrueType fonts in the game. And to do that, we're going to need something called SDL-TTF. This is another reason we're using SDL. So SDL-TTF is a little library that will render TTF fonts to an SDL texture for you. Now, after it does that, you have to then convert it to an OpenGL texture and render it to the screen. And that's a little bit intensive, actually, because say your font is changing every frame and you're using a high-resolution font, you're going to be constantly changing these big textures, especially if you're changing a lot of font at once. There's actually a little bit of an optimization we can do. We can use SDL-TTF to render a bitmap font sprite sheet. And what that is it basically takes all of the letters that you need, so maybe A to Z, all the numbers, whatever, and it renders them to a single texture, a single sprite sheet, basically. And then what we do is we map all the different letters to the UV coordinates for that bitmap font, and then whenever we want to render text, instead of asking SDL-TTF to render us a whole texture and do a bunch of processing, we simply render a different quad for each letter, so a different box for each letter. And we just render all the glyphs together on the screen, and it's much cheaper. We do have to make a lot of triangles if you're rendering a lot of text, because you need 2 triangles for every single letter, but it is going to be a lot cheaper than having SDL-TTF re-render the text over and over again, because that's not a very cheap operation. Luckily for you, we're not going to have to actually write the bitmap rendering stuff. It would have been a lot of work, and I feel like it just would have been a waste of time, because you don't really need to know how to do that. So what I'm going to do is provide you with the SpriteFont class that we use in Seed of Andromeda. Now, this isn't the exact SpriteFont class. This is a modification of our SpriteFont class that was created by Christian. I just wanted to change it a little bit so that it would work in our engine, and so it would be really easy to use. So I'm going to put another link to this as well in the description. Make sure you download everything that's in the description, and you can just pop this into your game. So I'll show you how to get all this installed right now. Let's start with just SDL-TTF. Now I'm going to put a link in the description for this as well. It should take you to this web page, their main web page. Otherwise, just Google SDL-TTF. And you'll see there's a lot of things you can download here. If you're on Windows with Visual Studio, you'll want to download this development library SDL-TTF vc.zip. If you're on Windows but you're not using Visual Studio, use the MinGW1. If you're on Mac OS, obviously use the only option. If you're on Linux, you're going to have to contact your distribution maintainer. I don't know, you'll just have to Google it. You may not be able to actually use SDL-TTF on Linux. Hopefully you can, because SDL-TTF is really, really helpful. Otherwise, you'll have to find a different solution. So get that downloaded, go ahead and download it, and drag it into your deps folder. Remember when we set up all our dependencies, we made a deps folder. And I made a folder called TTF, and I just extracted it into there. You should have an include and a lib folder, and then some random text files. So now what we need to do is drag the files in the include and lib folder into our deps include and lib folder. So in the TTF file, you should have an include SDL-TTF.h. Just copy that and put it in your deps include, and I made also a TTF folder here alongside SDL, GLM, and GL. So you should have something that looks like this. If you double click on TTF, you should have SDL-TTF.h in there. And you should also grab from the lib folder, if you're compiling in 32-bit mode, which is what we've been doing, I haven't taught you otherwise, so that's probably what you're going to do. Go to the x86 folder and grab this SDL2TTF.lib. Grab that and put it in your deps lib folder alongside all of the other lib files for all the other things we've had. And then one last thing you need to do, you need to go to the TTF lib folder again, x86 of course, and grab all of these DLLs, zlib, SDL2, TTF, and libfreetype. Grab all 3 of those and go back up to the directory above your deps folder into your debug folder and place them all there alongside sdl2.dll, and also place them in their same release folder alongside sdl2.dll. This will prevent you from getting that missing DLL error whenever you start up the game. So after that, there's one more thing you need to do. Go to your zombie game or whatever game you're making. Go to your properties and make sure you go to the linker and input, and make sure you add sdl2ttf.lib. I put it right below sdl2 main. That's that lib file that we put in our deps folder. So we've got to make sure to link to that. And that should be all you need to do to get SDL-TTF set up. Now to actually get the SpriteFont class that we made, just go into the description of the video and click on the link, and it should pop up with the download. Go ahead and download it, and then you should have a header file and a CPP file. Now what you're going to do is put them in your game engine, because these are going to be, like the Sprite batch, part of your game engine. So for me, my game engine is called Bingin. So I just drop them in here along with all of the other files we have, like the GLSL program, Sprite batch, all that. So you should have SpriteFont in here. Next thing you're going to want to do is go into SpriteFont.h and make sure that everything compiles correctly. So if you're using a different game engine and your game engine is not called Bingin, which is likely, just make sure to change this namespace Bingin to whatever your namespace is. And same thing in SpriteFont.cpp. Should also have that there. And you also are probably going to get, you definitely are going to get a compile error that's going to happen in SDL-TTF. So I'm going to right click here, open document SDL-TTF. So yours isn't going to look like this. Yours is going to look like this. I already fixed it. And you're going to get an error that says cannot find these files in this SDL-TTF.h. All you have to do is change it so that instead of include SDL.h, with quotes like that, it's include SDL/SDL.h. It just you just need to tell it where these files are, the same way that you do in all of your other files that use SDL. So yeah, you'll have SDL.h, you'll have SDL/begincode.h, as long as you're following along with the tutorials exactly, and this is where you put your files. If your SDL files are in a different place, then you'll need to do that. Change to that. And at the bottom, you'll have a close code here that had quotes. Just change that to SDL/closecode.h. And then you should have no more compiler errors. If you do have compiler errors, let me know. There could be some differences in how you're doing the include files in SpriteFont.h. I made some assumptions here, so just make sure that these includes are actually the way you have it set up as well. What exactly does SpriteFont do? It just has a few functions in here. Now I'm not going to show you all the code. Well, here's the code, but I'm not going to walk you through it. As you can see, it's pretty complicated. If you want to learn it, go ahead and just look through it on your own and try to figure it out. But you really don't need to learn it. Like with a lot of things in programming, you don't have to know how everything works. You just need to know how to use it. It may be useful for you to know how it works, but in this case, I really don't think it's that important. All right, so now let's figure out how to use SpriteFont. Let's go into maingame.cpp. And let's go ahead and use a SpriteFont. So let's go ahead and up here at the top include Bingin/SpriteFont. Like that. And I spelled it wrong. Uppercase Bingin. And now we need to create ourselves a font file. Or a SpriteFont. So let's go down here and we'll say Bingin SpriteFont. And it needs to be initialized like a pointer. With a call to new, so I'm going to make it a pointer. And what else do we need? We need a Sprite batch that will draw our Sprite font. Now we could reuse Agent Sprite batch, but I'm going to actually use a completely separate Sprite batch for this. So we're going to say Bingin Sprite batch, and this will be HUD. We'll say UI Sprite batch. No, we'll say HUD Sprite batch, since right now we're only using it for a HUD. Call it whatever you want, it doesn't matter. Alright, so let's start by initializing our HUD Sprite batch. And to do that, we go to, I believe, init systems. Here we go, and we'll initialize it right alongside Agent Sprite batch. Let me zoom in here. I know I've probably got a few of you who are running on lower resolution, so can't read what I'm doing here. Alright, we initialized HUD Sprite batch. Now let's go ahead and initialize our Sprite font. So, initialize Sprite font. Now you need to make sure this is initialized after you initialize SDL and after you initialize the shaders, or after you initialize OpenGL. Otherwise, you're going to get errors and your font will be completely black or something weird like that. So to initialize the Sprite font, we just say Sprite font. Did I not do the underscore? I did not. Underscore SpriteFont. So we're going to say SpriteFont equals new engine SpriteFont. So this will allocate it, and it will also initialize it, because we'll pass some stuff into the constructor here. And what I'm going to pass in is, so there's two constructors you can use. We have some overloaded constructors here. Where is it? SpriteFont.h. This constructor that has two parameters is the simplest one. It's probably the only one you're ever going to need to use. You tell it the file path of the font file, and then the size of the font, the resolution that you want it to render in. Now, the higher this size, increases the quality. 32 pixels is usually good enough, but you could go all the way up to 64, maybe even higher if you want to. But I wouldn't go too high, because this will crash if your SpriteFont texture is bigger than 4092 by 4092. So yes, that's the only SpriteFont constructor you really need to use. If you want to specify different start characters and ending characters for rendering the font, then you can do that using the other constructor. But for now, it's going to use all ASCII characters between 32 and 126, which will encompass numbers, symbols, pretty much most of the ASCII chart is included there. So that should be all you need. All right, so let's go ahead and initialize it. And our font file is in, if we go to zombie game, it's in, I put it in fonts / chintzy ttf. So fonts / chintzy.ttf. Did I spell it right? Chintzy, yes. And then I'm going to use 32-point font. Now that doesn't mean you can only render it at 32 points. You can scale it up and down. That just changes the actual size of the texture that it renders to. So that'll change the quality. Alright, so that initializes our SpriteFont. Now let's render a basic heads-up display using our Sprite batch. So what we're going to do is, after we draw all the bullets and everything and all the zombies, we're going to draw the heads-up display. So let's go ahead and make a new function that will handle drawing the heads-up display. We'll put it right below draw game. Draws the HUD. So we'll say void draw HUD. And this is just to give us a little bit of a separation so we don't have all of the code in the same place down here. And let's put it in here and make sure we specify that it belongs to main game. Alright, so we're going to say HUD spritebatch.begin. And then we'll have a HUD spritebatch.end and a HUD spritebatch.renderbatch. And then in between here, we're going to render everything that we want to render for our heads-up display. So let's start by just rendering one thing of text to see if it even works, and then we'll worry about kind of making it pretty. Let's go ahead and let's render the number of humans remaining. I believe we have a variable for that. We can render humans.size. We can just do that. So to do that, we're going to need to render it to a string. And one thing we can do with that is we could use a string stream. I'm not sure if I've taught you string streams. Probably should have, but I may not have. We could use just a regular string and concatenate it in a weird way, or we could use SPrintf. I'm going to use SPrintf. So the first thing you need to do is create a char star buffer, or a char buffer. Basically, this is a C string that is bigger than you would possibly need. You want to make sure you're not going to overflow this. So we're not going to use more than 256 characters, right? So we'll say char string, or what we'll call it char buffer, and we'll say 256. That's plenty big. I'll go ahead and declare it at the top, and we can reuse it for all of the strings that we create. Alright, and now what we want to do is put a string into this buffer that we can render. And remember, this is only one way to do it. There's other ways you can do this. So we're going to say sprintf. So it's just like printf, except instead of printing it to the screen, it prints it into this char buffer. That's all you need to know about it. It's really simple. So first we need to tell it the buffer. We just say buffer. Then we need to say the format. So we're going to say num humans. And then we'll say %d. Just like your regular old printf. And then we're going to say humans.size here. And that is that. So that will basically fill this buffer with this string. And then now we can render that string to the screen. So we're going to say, we're going to call our SpriteFont draw function, SpriteFont dot, or arrow draw. And we're going to pass in our sprite batch that we want to render to. So HUD sprite batch. And we are going to pass in the const char star s, which is the string that we want to render. In this case, we're going to render a buffer. If you were using an std string, remember you have to call the .cstring function first. Now we want to say the position. Now for now, I'm just going to put it in a random position just so we can see if it works. We'll put it at 300, 300. It's completely arbitrary. And the scaling, this is how big we want it to be. I'm going to say vec2 4. So this will multiply our 32-point font by 4, which should give us 128-point font. Oh god, excuse me, 128-point font. And let's see, that's scaling. Now for the depth, I'm just going to put 0.0f since we're not really doing any depth layering or anything like that. For the tint, so this is the color that you want it to have. We need to create a color, so I'm going to say color RGBA 8. And I'm going to say just 255, 255, 255, 255. So that will give us a solid white color for our text. But you could give it any color you wanted. And this is actually Benjin : color RGB8. Now this line is getting really long, so I'm going to come here in the middle and press enter and put it over on the next line. It's actually a good thing to do. Some people, or a lot of people, really prefer if you keep the size of your columns, or the size of your lines, less than 80 characters. So there's our color, and then finally, if we want to have a justification, we can do that. We can say Benjin justification right, and what that's going to do is it's going to line up this position with the right side of the text, so the text is going to extend from the right. If you've ever used like Microsoft Word, you can change the text justification. It's the same thing. You can also do center or left, but there's no need to specify left because left is the default. So if you're doing left justification, just don't even worry about that last parameter. All right, so now let's see if we get some rendering going on in here. If it doesn't work, I'll have to pause the video because I don't think I've forgot anything. Oh, unless we have a compiler error. SprintF may be unsafe. Oh, right. Visual Studio prefers SprintF_s. Let's see if that works. And I don't see any text, so I'm going to go ahead and pause the video and see what I did wrong. Okay, yeah, I'm done. I never even called draw HUD, so this text rendering stuff never actually happened. So let's see, we're going to go right after agent sprite batch.render batch, we'll call draw HUD. Heads up display. Now let's see if it works. Fingers crossed. Maybe we'll get a crash. There we go. So as you can see, it is rendering some text there. Can I zoom in? I don't have that functionality, no. But as you can see, it's counting down from 1,000 as humans die. We've got 920 humans, and it's just dropping and dropping. However, you'll notice as I move around, it stays in the same place. That's because we are rendering that text with our main game camera. What we actually want to do is use a separate camera that renders the heads-up display, a camera that doesn't move around. And that's actually going to be really easy to do. We're just going to come to where we declare our main camera here. We'll make a new one, and we'll call it HUD camera. Okay. And now we just need to initialize it like we did the normal camera, except when we update, we're not going to move the camera around. And we're going to keep the scale the same. So where do we... Here we go, camera.init. We're going to do the same thing with HUD camera. .init, screen width, and screen height. There we go. And now all we got to do is change our code to use the HUD camera down here whenever we... Oh, and we need to update the camera. Let's see. Where does that camera update? That happens right here. So we're going to call HUD camera.update, but we're not going to call HUD camera.setPosition with player arrow get position. All right, and now what we need to do is you'll notice we're doing some stuff with the camera matrix right here. All we need to do is basically copy this and do the same thing except with the heads-up display camera. So we're going to put that in draw HUD down here. And instead of camera, get camera matrix, it's going to be HUD camera.get camera matrix. So now when we move around, it should stay in the same place. Let's see if that works. There we go. It's staying in the same place, and it's really large because it's not taking into account any scaling. And so it's like way up at the top right-hand corner of the screen. Let's bring the scale back to 1. Let's bring the X to 0. For Y, let's say 150. See what that looks like. There we go. So now it's in the middle of the screen. And actually, right, because the camera position is in the center. So what we're going to want to do is whenever we initialize our camera, where are we? HUD camera.init. Let's go ahead and also say HUD camera.set position. And the new position is going to be glmvec2. We're going to basically offset it to the right so that it correctly lines up with the left side of the screen. So the Y will still be 0, I believe, but the X is going to be screen width over 2. I think that's what we want to do. I may have gotten it backwards. Let's see. We'll run it now. Basically, if you remember, 0 is the center of our camera, but that's not what we want it to be for the HUD camera. We don't want 0 to be the center. Let's put this at 0. I believe we should also be offsetting the Y by screen height over 2. We definitely should. Yep, so there it is in the middle. Now we just want to change this to screen height over 2. And now it should be at the very bottom left-hand corner. There we go. So we have num humans down here. As I move around, that stays in the same place, and it does not change. So now you know how to do font rendering. We could do, let's go ahead and do num zombies as well. So there's num humans, and we'll draw that. Let's also do the number of zombies. Num zombies. And this is going to be zombies.size. And instead of rendering it at 0, we're going to go ahead and render it, we'll say 32 pixels higher. We'll do 36 pixels higher. That'll be good. Now let's see what that looks like. There we go. So now we are counting the number of zombies down there and the number of humans. And I really don't like this font. Feel free to choose a different font if you want. So you'll notice the quality is alright, but the quality could be better. Let's see what happens if we up our resolution to 64. Let's see if we can get it to do that without crashing or anything like that. If we change that to 64, should still fit inside our texture just fine. There we go. So now it's bigger as well, because when you change the font size to 64, you end up doubling the size. So we're going to want to change the scaling to 0.5. Since we doubled the font scale, or since we doubled the font size, we should half the font scale. So now if we render it, it looks exactly the same, except it's a little sharper. It's got more quality. And it's not going to really cost us anything more. It'll cost us a little bit more texture memory, but other than that, it should be fine. Now, upwards of 64, you're probably going to run into an error because the SpriteFont class will only make, like I said, I believe if we go to SpriteFont.cpp, you can see for yourself, it will only make a texture that is 4096, no greater than 4096. Basically, it's concerned that you might be passing in something that's way too big and you're going to destroy your video memory, and some graphics, some graphics cards are not able to even hold textures bigger than that, some really old ones, but yeah, it's up to you. If you want to come in here and change this 4096 number, I'm going to actually make a little bit of a modification. Define max texture res 4096. So I'm not going to change this all right here in front of you, but Just whenever you download this file, if you want to change the maximum resolution that you can have, just come in here and change it. Make sure it's a power of 2. The next step up would be 8192 if you want to go bigger, if you're worried about size, but 4096 should be fine. Thanks for watching. In the next few tutorials, we're going to be doing some audio, and then we should have most of the core components of our little game engine in so that we can actually make some fun games. And I'll probably do some particle stuff since particles are neat. We want to get maybe some blood effects and stuff, and we're really nearing the end of this tutorial series, I think. We're probably going to do spatial partitioning, and if there's anything I forgot, those of you who would know a lot about OpenGL and stuff relating to 2D games, please give me some suggestions in the comments, and I will consider doing some tutorials that you guys suggest. We will be doing 3D graphics in a separate tutorial series. It's not going to be this tutorial series. It will be the one after it. And we will also be doing a voxel engine tutorial series kind of at the same time. So thanks for watching, guys. I will see you in the next video.